Welcome students. Today we will discuss about how to solve max sign problem using differential evolutionary algorithm. We have already seen what is the function for max sign problem. You can see x dash is equal to sigma over I xi into 2 power I minus 1. That means x dash is a integer form of binary x, and f of x is 2 pi sin pi x dash by 2 power d. F of x is equal to sin pi 2 x dash by 2 power d, where d is a dimension. So you need to find the optimum value using differential evolutionary algorithm. Let us see the implementation. We already told you the differential evolutionary algorithm is available in this library package. So you have to load the first thing, and the next thing is implement the max sign function. So first of all, we are writing a function for converting a binary to integer, and then we are implementing the max sign function. You can see, so x receives a binary vector, and then we are converting into binary digits, and then we are converting into the integer format. So that means x is a binary vector and x1 is your integer format, and then we are returning sin pi x 1 by 2 power d. That means it is the exact same implementation as this one. So instead of x dash, we are calling as x1. So nothing more than that. And after that, we have to define the dimensionality. So you can see here in this program, dimension is taken as d is equal to 8. So let us take the dimension. In the question it is given as 8. So we take the dimension 8 and then set the number of iterations, maximum number of iterations as 100, and then define the control list. That is important. Control list for differential evolutionary algorithm is set by using this function DEoptim dot control function. So pass the arguments. Strategy 1, by default strategy will be equal to 2, and then set the population. NP is population size as 5, and set the maximum number of iterations, and then set the crossover probability, and then set the scaling factor, and then how to store the results, and then from which population you have to store the results, and then the frequency. So once we set the control list parameters, and you can call the algorithm DEoptim algorithm, and first pass the max sign function, and then lower vector of lower range of values and vector of higher range of values. Actually it is 0 and 1 only, so that's what we are representing. And then finally control list, so which we have defined in the earlier function. So after that you can see the results with the help of summary function. For this summary function you have to pass the output object d, and then finally you can plot the output object, plot d. So actually this statement is used to compress the plot, to scale the plot, so that it will be visible in this window, right side window. And after that print the best optimum value and its fitness value. Okay, solution and then its fitness value. You can see the output of DEoptim function is also a list containing two members, these two members, and each member is again a list containing two another elements, best solution and best evaluation value. So you can see this. So that's why we have used the dollar symbol to print the results. So let us see the execution. Let us execute one by one. So we executed the control list and then algorithm, and then you can see, so you can see the summary of results. This is the best solution. So you can see the dimensional is 8, 1, 2, 3, 4, 6, 7, 8, and then you can plot the population also. So, and then we can see the results also. So you can see the results for different parameters. So here 8 dimensions are there, or 8 parameters are there. For each parameter, you can see path 1, parameter 1, 2, 3, and 1, 2, 3. You can see this. For each parameter, you are having the population size as P5. So you have to analyze from vertical direction. At 0th iteration or first iteration, you are having 5 values for parameter 7. Like this, you have to analyze. So you can use this arrow symbol to see the previous plot. Actually, these are the values taken care by the corresponding parameters. Okay. Okay, students. So for finding the final best value, you can use this, execute this statement, and with the help of DEoptim, you can access the best solution and best value. So this is the minimum optimum solution. So you can plot the population for 8 variables. Actually here the dimension is 8 is given in the question. So we can print all these 8 variables, and each variable can take is having a population of 5. So that's what it is displayed here. Here x-axis represents the iteration and y-axis is the value. Okay. Okay. Thank you, students.